Hi guys, this is Miss Katz, and today we're going to do the first side of your Unit 4 study guide answer key. So pay attention, and if you've got any questions, you are welcome to come in and ask me about them anytime. So let's jump right in. First of all, I am well aware that there is a typo, and the first one to find this typo will get a Jolly Rancher because that's how I roll. This was taken from your test. I mean, these are questions that are going to be just like what you see on your test, and on your test there's multiple choice options, so I just forgot to take that off. In the meantime, question number 1 says, list out the characteristics of a direct variation graph. Okay, where does it start and what does it look like? So a direct variation graph starts at 0, 0, which we call the origin. Okay, that is where it starts, because if you do nothing, you have nothing. If you haven't worked a single hour, you haven't made any money. Those kinds of things. That's the relationship in a direct variation model. Okay, and then it is always a straight line. In a direct variation model, the rate of change is constant, which makes for a straight line always. All right, question number 2 asks us to solve the equation. And remember, we're going to do 4 steps. So first one is inverse operations. Oops, let me move that over so you can see it. Okay, we're going to zoom in a little bit, and hopefully I won't cut you guys off. Step number 2 is going to be solution, find that answer. Step number 3 is to substitute it back in. And step number 4 is to do the math to check to make sure you're good. Okay, so every time you solve an equation, we need to see those 4 steps. So in this particular case, what's happening to x? It's being multiplied. How do I undo multiplication? I'm going to divide. Don't forget that we divide on both sides of the equation. Okay? So this means x will equal 42 over 1. I'm going to make that divided by 1 over 5. Remember, any whole number can be made into a fraction by putting it over 1. Okay, so x will equal 42 over 1, then times, because remember, we're going to keep the first fraction, change to multiplication, and flip this one over to make it a reciprocal. Okay, so in this case, x will equal, let's do 42 times 5. That's 210. Okay, so here's step number 1, way up here. That is your inverse operation step. Step number 2 is getting that solution. Okay, step number 3 is to substitute it back in. So I want to know what 1/5 of 210 is. It should equal 42 if we did this right. So take 210, multiply it. I'm going to do that on a Post-it note so you guys can see it without interrupting space because I'm running short. By the way, all these problems should be done on a separate sheet of paper. I didn't leave you enough room to do them on the study guide. But if you look at this problem, what this means is 1/5 times 210 over 1, which will equal 210 over 5, which means 210, oops, sorry guys, divided by 5. Okay? And when we do that, 5 goes into 21 4 times, and into that 2 times. Now I can see that this side is 42, and that equals the 42 we were looking for. That's step number 4. We are good to go. Okay? In question number 3, the inverse operation of addition is subtraction. So we're going to subtract 67 from both sides. The C will equal, these make a 0 pair. They disappear, they're gone, because if I add 67 to something but I take it away, I'm back to where I started. And I'm going to subtract here. So C equals 116. So here's step number 1, step number 2. Step number 3 is the substitution. So 67 plus 116 should equal 183. 116 and 67, 13, 8, 1. I know it's 183, and that equals the 183 I was looking for. That's step number 4, and I am good to go. You can walk out of your test knowing you got all these equations right because you're checking them as you go. Okay? Question number 4 is a subtraction equation. The inverse operation of subtraction is addition. And remember, when we add decimals, we have to line them up. So here's 12, dot, and then 10. So it's 10.2. J should equal 10.2. Here's step number 1, inverse operation. Step number 2, the solution to our equation. Step number 3, we're going to substitute it back in. So that 100 or 10.2 minus the 5.6 should equal 4.6 if I did this right. Sorry, I'm running off the page. Let's actually do that. 10.2 minus 5.6. Remember that decimal's real heavy. It just falls right down into place, and you have to line them up. So this 10 is going to turn into a 9, and I'm going to regroup. And I get 4.6. Since I get 4.6 on the left and 4.6 on the right, I know I'm correct. Okay. In question number 4, and we may need some more post-it notes here, it says that Jennifer spent $8.99 on a bag of Jolly Ranchers that cost X dollars a piece. If there were 110 Jolly Ranchers in the bag, we have to write an equation that could be solved using inverse operations to find out how much each Jolly Rancher would cost. You don't need to solve it, we just want the equation. So if the bag, I spent $8.99, the Jolly Ranchers cost X dollars a piece, and there are 110 Jolly Ranchers in the bag. I want to know how much one Jolly Rancher would cost. Okay? So here's the deal. If I take the 110 Jolly Ranchers that are in that bag and I multiply it times the cost per Jolly Rancher, I will get the total I spent. So one possible graph is 110 Jolly Ranchers times the cost per Jolly Rancher will equal $8.99. And that would probably be the best equation here for using inverse operations. You could also see that if I take $8.99 and I divide it by the number of Jolly Ranchers in the bag, or I mean how much each one costs, I will get the 110 in my bag. Either one of those equations is legit. The one that I would see most often based on what you guys know right now would be that equation. All right, write a situation that could describe the following inequality graph. So first of all, let's identify what's going on here. 2 is not a solution set in the solution set for this inequality. It's saying that anything that we're talking about has to be bigger than 2. So we could write something that says you will receive more than 2 points extra credit on your test. There are an infinite number of answers to this particular question, but there's an example of how we could relate this inequality to a statement. So it's saying that you're going to receive more than 2, not 2, more than 2 extra credit points on your test. All right, number 6 says write an inequality to represent the fact that there are at least 13 questions on your test. Now, when we did this in class, what we talked about was, first of all, we're comparing X and 13. X represents all the possible numbers that would make this thing true. 13 is the number that we're dealing with. And it says at least. So you have to ask yourself, if it can be at least 13, does that mean 13 can be in the solution set? And the answer is yes. So we put the equal to sign at the bottom. Then you ask yourself, what's a possible value for X that would make this true? If there are at least 13 questions, that means there's 13 questions or more. So this number could be 14, it could be 15, it could be 100, whatever it is. We want to put a little test number here. And then we look, which one would the alligator want to eat? Which one is the bigger number in the set? That's where we always open the mouth. So X is greater than or equal to 13 would be the appropriate inequality to represent that situation. In question number 7, it says write an inequality to represent that there are more than 125 cars in the parking lot. So the two things we're comparing are X and 125. And we want to look. More than 125. Give me a number that would make that true. A number that's more than 125 is, let's say, 200. Okay? So now we're going to look. Would the alligator rather eat 200 or 125? It would rather eat the 200. So the inequality X is greater than 125 is correct. Now the reason we don't include the equal sign here is it's got to be more than 125. 125 is not more than 125. It's equal to. That wasn't an option here. All right, in question number 8, it says Gabriel wants to solve that equation, and which step should he do to isolate the m on one side of the equation? To isolate the m, that just means how would he solve this equation? We use inverse operations. So what's happening to m? It's being multiplied by 3/4. So we are going to divide by 3/4, and it really should be on both sides of the equation. If you find that mistake first, then please, by all means, let me know, and that will be a Jolly Rancher. So the inverse operation of multiplication is division. All right, Judy spent $5.67 on oranges that cost 63 cents each. If X equals the number of oranges, write an equation that would determine how many oranges she purchased. Well, if we take the cost per orange times the total number of oranges we're going to buy, that will equal the amount of money that we spent on oranges. Okay, in question number 10, write a direct variation equation to represent the data in the table. What we want to look at is every time we do this, to get from 1 to 5, times 5, times 5, times 5. 5 is the constant of variation, so our k equals 5. The generic equation for a direct variation model says that all of our y's will equal whatever k is times whatever x is. And the only thing you have to plug in to get me a good direct variation equation is the k. So the direct variation equation that works here is this. Write one possible solution and one non-solution to the inequality x is greater than 4. So give me any number that is greater than 4. So a solution could be 5. That's greater than 4. A non-solution would be anything that's not greater than 4. That's 0. Any number on the other side. Explain how to solve an equation. 1, inverse operations on both sides. 2, solve. 3, substitute. 4, check to make sure that the number you substitute in works. All right, let's complete the direct variation table for this equation. So y equals 12x. If they give us the x, we're going to plug that in. So here, y equals 12 times 1 would be how we solve this first one. So it's going to be 12. The second one, they give us an x. Y equals 12 times 2. I'm going to bump that up, guys. Sorry about that. Okay. And so y will equal 24 here. Now, if I know the y, in this case, it's going to be 48 equals 12x. How do I solve this equation? Inverse operations. Divide by 12. X will equal 4. And here, y equals 12 times 5. So 12 times 5 is 60. What inequality is graphed on the number line? Well, we know we've got x and 2. Because it's filled in, we have an equal to. And give me a number that works here, 4. 4 would work. So is the x or the 2 going to be bigger? If 4 is our test site, it's going to go that direction. Okay. And in the bottom one, we've got x and 4. We do not put an equal to sign because the dot is not filled in. And then all we have to do is look at an example. So 2 is an example that works here. So the alligator is going to want to eat that number. So this one is x is greater than or equal to 2. And this one is x is less than 4. Guys, I hope this helps. Stay tuned for slide number 2.